Statistics 3, confidence intervals, type 2, different confidence intervals. So we have a random sample of 40 women were selected from a population and their pulse rate was measured. The mean pulse rate of the sample was 76.3 beats per minute. So that's our sample mean. And we have to assume that the standard deviation of the population is known to be 12.5 beats per minute. So part 1 wants us to construct our 95% confidence interval for the mean. So we know our 95% confidence interval for the mean is given by the sample mean plus or minus 1.96 times sigma over root n. In other words, our sample mean plus or minus our margin of error, where 1.96 is our critical values and sigma over root n is our standard error of the mean. So if we write down what we're given first of all, well, we have our sample mean is 76.3 beats per minute. Our standard deviation is 12.5 beats per minute. And our sample size is 40. So if we set up our 95% confidence interval, what we're going to do is write it out as full. So it's the sample mean plus or minus our margin of error must be less than or equal to the true population mean, our sample mean plus our margin of error. Okay, so subbing in our values, we have 76.3 minus 1.96 times 12.5 over the square root of 40, less than or equal to mu. And then we have 76.3 plus 1.96 times 12.5 over the square root of 40. So we put that all into our calculators, then what we have is 72.46 less than or equal to mu, less than or equal to 80.174. So this is our 95% confidence interval. In other words, we are 95% confident that our true population mean lies within the interval of 72.426 beats per minute and 80.174 beats per minute. Okay? In other words, we are 95% confident the true population mean lies in the interval, where the interval is 72.426 to 80.174 beats per minute. Okay, so in part 2 we're going to be looking at the margins of error for 90% to 99%. And you can see here what you'll notice is that we have these numbers 1.645 and 2.575. So basically they are the critical values if you're looking at a 90% interval or you're looking at a 99% interval. So you can see it's above and below 1.96. So again, as I said, the 95% confidence interval is the one that you will be focused on for the Leaving Cert, but this is just an interesting question to construct it for the 90 and the 99% and see how does that affect your confidence interval. Okay, and then it says comment on our results as well. All right, so let's have a look at part 2. So the 90% confidence interval, we'll go with that one first. Mean. And we have the sample mean plus or minus, and it's 1.645 sigma over root n. Okay, so subbing in our values, well, everything else is the same except for the confidence interval. So what we have is 76.3 minus 1.645 times sigma, which was 12.5 over root n, where n was 40, less than or equal to mu less than or equal to 76.3 plus 1.645 times 12.5 over root 40. Okay, so if I put all that into my calculator then, that gives me 73.049 less than or equal to mu less than or equal to 79.551. Okay, so we have a different confidence interval here. So in other words, we are 90% confident that the true population mean lies in the interval of 73.049 beats per minute to 79.551 beats. So 79.551 beats per minute. So we can see what we have here is we've got a narrower range. So if I subtract those two numbers from each other, I can see the range is 6.502. Or if I go back to the 95% confidence interval, our range of the interval was 7.748. So we've got a narrower range, but we're also less confident because it's 90% confident as opposed to 99% confident. So what happens then if we look at a 99% confidence interval? So again, we have our sample mean plus or minus our margin of error, where our margin of error is 2.575 sigma over root n. So again, if I sub in my values, well, it's still our sample mean 76.3 minus our critical value is different because we're looking at the 99% confidence interval. Our standard deviation is still 12.5 and our sample size is still 40. So then if we go 76.3 plus 2.575 times 12.5 over root 40. Okay, so putting all that in to our calculators, we end up with 71.211 less than or equal to mu, which is less than or equal to 81.389. Okay, so this is our 99% confidence interval. So again, we say, i.e. we are 99% confident the true population mean lies within the interval of 71.211 beats per minute and 81.389 beats per minute. Now, of course, here if we're looking at the range, well, what we can see, however, is that the range has now widened. Our confidence interval is much bigger. So obviously we're going to say we're 99% confident because it's a much bigger gap. So it's kind of like, you know, the wider the confidence interval, the closer you're going to be to that the answer is definitely within that interval. So, you know, we don't really like going with 99% confidence intervals because they're too wide. And obviously with the 90% confidence interval, yes, it's a narrower range, but of course then you have to be, we can't be as certain because it's you know, it's not going to be as accurate. So we always stick with the 95% confidence interval. So what we say as a conclusion there for part 3, I was just commenting on it, is therefore we can say, therefore, as the confidence interval increases, as the confidence level, I should say, increases, so does the confidence interval. i.e. a greater confidence level implies a wider confidence interval. Okay,